Hello everyone, welcome to my channel. Let's learn computer science. Hello everyone. Today we are going to start with Unit 3's second part, that is logic gates and logic circuits. And in today's video, we are only going to cover basic logic gates, their symbols, their functions, and then next constructing logic circuits, constructing truth tables and logic expressions we'll cover in the next video. So let's begin. Imagine your parents tell you you can go out and play only if you finish your homework and clean your room. Now think carefully. What happens if you complete your homework but don't clean your room? You still can't go outside, right? Why? Because both conditions must be true. Interestingly, computers think in exactly the same way. Computers make decisions based on conditions, and these conditions are made using something called logic gates. Now, in today's session, we are going to learn what logic gates are, truth tables, So let's get started. First of all, let's understand what are logic gates. Logic gates are the building blocks of logic circuits. Think of them as tiny decision makers inside electronic circuits or electronic devices. And their job is very simple. They take one or more binary inputs and produce a single binary output. Now remember, computers they only understand two values. 0 means false, 1 means true. Just like a light switch, on or off. Off is 0, on is 1. Everything inside a computer ultimately works using these two states, on or off, 1 or 0, right? So where are logic gates used? You use devices containing logic gates every day. For example, your mobile phones, when you unlock your phone using a fingerprint, the phone checks, does the fingerprint match? Yes, no. And that decision is made using logic circuits or logic gates. Computers, every calculation, every comparison, every instruction depends on logic gates. Security systems, imagine a security door. The door opens only when password is correct and fingerprint matches. That is literally an AND gate in action. And when these several logic gates they are combined together, they form logic circuits, right? Now let's talk about truth table. What is a truth table? Before learning the gates, we need to understand truth tables because a truth table, it shows all the possible combinations of inputs and their corresponding output. Now think of it like an answer sheet showing what happens for every possible situation. Now there are some important points regarding truth tables. So truth tables are used to trace the output from a logic gate or logic circuit. NOT gate is the only logic gate with one input, and all other gates they have two or more inputs that can be 2, 3, 4, 5, any number of inputs, right? Now, when constructing a truth table, remember that all possible combinations of ones and zeros which can be input are considered. For example, if you have just one input, that means you can make two combinations of it, 2 raised to power 1, right? So one input means 2 raised to power 1 combinations because base is 2. You have only two numbers, 0 and 1. And if there is only one input, that means that it can either be 0 or it can be 1. So that means there are two possible combinations of input, right? Now, if you have two inputs, that means 2 raised to power 2, that is 4 combinations. So if you have two inputs, 0 and 1, so you can have combinations like 0, 0, 0, 1, 1, 0, 1, 1. So in total, 4 combinations can be there. So every time you have number of inputs, you just put it as 2 raised to power number of inputs and you get how many combinations will be there. So if it is 1 input, 2 raised to power 1 combinations. If it is 2 inputs, 2 raised to power 2 combinations. If it is 3 inputs, 2 raised to power 3 combinations, and so on. And this is very, very important from exam perspective also, because sometimes they ask questions related to this. And whenever you have to create your truth tables, you need to remember that how many combinations are to be placed there in the truth table. Also, you need to remember that in the Boolean algebra, a dot represents AND operation and a plus represents OR operation. Now, where it is used, how we use it, that you will understand in some time. Okay. Now, let's start with logic gates and their functions. And first and very basic and the easiest one is NOT gate. NOT gate is also sometimes known as invert gate. So the NOT gate, it has, as I said, it has only one input and its job is just to inverse the input. So if you're getting 0 as input, your output will be 1. If you're getting 1 as input, your output will be 0. So whatever you're getting as input, output is just the opposite of it. And if you look at here, this is the symbol of NOT gate, a triangle followed by a circle. So circle represents the everything, whatever is getting inputted, it is getting reversed, right? If people ask what is the function of usage of, NOT gate, so in that case, you just need to say that it is used to invert whatever input you are getting, invert the logic, turning 1 into 0 or 0 into 1. And this is used in control systems. Let's have a look at its truth table. So as I said that there is all the combinations of input represented in a truth table. So as NOT gate is having only one input, so two combinations, 2 raised to power 1, so it can be either 0 or it can be 1. So whenever input is 0, output is 1. Whenever input is 1, output is 0. So like that. So that's your NOT gate. Now let's move towards AND gate. Now AND gate gives output 1 only when all inputs are 1. So it can have 2 or more inputs. As I said, this is the symbol. A, B, that means you can have 2 or more inputs. And then output is A dot B. So dot represents AND operation. So AND gate, it gives 1 only when both the inputs or all the inputs are 1. Right? So this is the truth table with 2 inputs. So if input is 0, 0, A is also 0, B is also 0, in that case output is 0. Any one of these is 0, then in that case also it is 0. But when both the inputs are 1, in that case you get output as 1. Now this is with 2 inputs. This is a truth table with 2 inputs. Now when we have 3 inputs, that is A, B and C, in that case, your combinations in the truth table, they are 2 raised to power 3, right? So 2 raised to power 3 means 8 combinations. So here, first one, C, 0, 1, 0, 1, 0, 1, 0, 1. Second one is B, where it is changing 0, 0, 1, 1, 0, 0, 1, 1. This is a standard way of writing, inputs. So if it is A, it is this 0 is changing after 4 bits. So as you have learned, binary number system and conversions, you know the logic that first one is 2 raised to power 0. First place value is 2 raised to power 0. So bit is changing after every 1 bit. So 0, then 1, then 0, then 1, then 0, and then 1. Second place is 2 raised to power 1. There, bit is changing after every 2 bits, 2 numbers, 0, 0, then 1, 1, then 0, 0, then 1, 1. Third place is 2 raised to power 2, which is 4. So bit here number is changing after every 4 bits. So 4 zeros, 4 ones. If you have 2 raised to power 4, 2 raised to power 3, in that case you have your bit changing after every 8 bits, 8 zeros, 8 ones, and so on. And that is in case of 4 inputs, right? So this is how you write combinations of inputs. So these are all inputs. Now their output that we get is, we get 1 only when all the inputs are 1. Otherwise it is 0. Any one of the inputs is 0, you get a 0 in case of AND gate. Okay. Now comes, this is, I have also created a table with 4 inputs. So 4 inputs A, B, C, D. And here, these are your combinations. So here, as I said, first input is changing after every bit 0, 1, 0, 1, 0, 1. Second one is changing after 2 bits 0, 0, 1, 1, 0, 0, 1, 1. Third one after 4 bits 0, 0, 0, 0, 1, 1, 1, 1. And then it is 8 zeros, 8 1. So in total you have 16 combinations, right? So 16 combinations are there. And because it is AND gate, so any one of the inputs, if it is 0, your output is 0, and you get 1 only when all the inputs are 1, right? So that's your AND gate. Now let's move towards OR gate. Now OR gate is, it gives you output as 1 when any one of the inputs is 1. So at least one input is 1, you get output as 1. This is the symbol, okay? And OR gate is represented by plus sign, A plus B. A and B are inputs, A plus B is the output. And function of OR gate is, it is used when any one condition is enough. And, you know, turn on backup light if main fails or sensor triggers, or when there is an option either this or that, in that case you use OR gate. This is a truth table with 2 inputs. Now as I said, if any one of the inputs is 1, that time you get 1. So here both the inputs are 0, so output is 0. But here if you see 0 1 1 1 0 1 1 1 1, right? So A plus B, any one of the inputs, if you get it as 1, your output is 1, and you get 0 when both or all the inputs are 0. Now this is a truth table with 3 inputs. Now 0 1, C is 0 1 0 1 0 1 0 1, B is 0 0 1 1 0 0 1 1, and A is 4 times 0 4 times 1. Here also you get 0 as output when all the inputs are 0, and you get 1 as output when any one of these inputs A, B or C is 1. So in all these cases you have at least 1 as input, so accordingly your output is 1 here. Okay, now you will create a truth table with 4 inputs yourself for OR gate. I have not created it for you, right? Then comes NAND gate. Now NAND gate is AND followed by a NOT gate. So this is your AND gate, and this circle represents that this is a NOT gate following your AND gate. So if it is a AND gate followed by a NOT gate, that means that it is reversing or it is inverting the output of AND gate. So if AND gate's output is 1, it is converted into 0. If output is 0, it is converted into 1. So exactly the opposite of the output that we receive from AND gate is the output of NAND gate. So let's have a look. This is also known as a universal gate. Please remember, we can build all other gates using these 2 universal gates, NAND and NOR. Okay. Truth table with 2 inputs. Now, if you look at, this is not of A dot B, right? So in AND gate, this is also 0, this is also 0, this is also 0, but this is 1. But here in NAND gate, these all 3 are 1s, and here it is 0. So just the opposite of AND gate, right? Now, this is truth table with 3 inputs. Again, I have not created a truth table with 4 inputs. That's your task. You will create that. However, as you know, in AND gate, all these were 0. Only this was 1. But here in NAND gate, it is exactly the opposite of NAND gate. Okay, now let's talk about NOR gate. NOR gate, it outputs 1 only when all inputs are 0. Okay, now here, have a look at the symbol. So, symbol is NOT gate plus OR gate. So, OR gate is followed by NOT gate. So, you perform OR first and then reverse the answer. Okay, so if you look at this is also known as universal gate. As I said, you can create all other gates using these two gates, NAND and NOR. Now, this is truth table with two inputs. If 0, 0, output is 1. If 0, 1, output is 0. 1, 0, output is 0. 1, 1, output is 0. So exactly the opposite of OR gate. This is truth table with three inputs. This is also exactly the opposite of what we got in OR gate. So you perform OR first and then you just invert it, right? The next gate is XOR gate. XOR gate is also known as EOR gate. XOR means one or the other, but not both. Okay, you get one as an input only when both the inputs are opposite to each other. When they are same, you get 0 as an answer. Okay, this is the symbol OR gate. In front, there is one more arc. This is used in comparators, parity checkers, digital addition, encryption, etc. This is the truth table and this is the symbol that we use here. Okay, plus within a circle. So when both the inputs are same, we get a 0. Either it's 0, 0 or 1, 1, you get output as 0. You get 1 as an output only when both the inputs are opposite to each other. Okay, different, dissimilar. Okay, truth table with three inputs. Now here, firstly, you will see 0, 0, it gives you 0. 0 and 0, it gives you 0. 0, 0 gives you 0. 0 and 1 gives you 1. So this is very important that you need to firstly figure out output of first two values, and whatever you get as output of first two values, then you know, put them in the XOR gate with the third input, and then you can't see three as together. So always put two values at a time and then you figure out the output. So here, the next one, if you see, this is 0, 1. So that means it is 1 as an output, and 1 and 0, it is 1. Okay. Here, 0 and 1 gives you 1, but then 1 and 1 gives you 0. Okay. So that is how this is the truth table with three inputs. Okay. That's all for today. Okay. So today we have covered use of the following logic gates: NOT, AND, OR, NAND, NOR, XOR, and we will cover rest of the topics in the next video. That's all for today. Thank you for watching. I'll meet you in the next video.